In this video, I'll be working the probability worksheet that I would normally work in a class. So, a drawer contains 3 colors of socks, white, black, and gray. How many different socks must be taken out of the drawer and not replaced in order to be sure that you get a matching pair? Well, the answer is 4. Why is the answer 4? Well, in the worst case scenario, you would take out 1 white sock, 1 black sock, and 1 gray sock. The next sock, no matter what color it is, would produce a pair with one of the socks that was already pulled out. So in order to guarantee that you'll get a matching pair, you need 4 socks. Sam has 5 different trophies and wants to display them in a line. How many ways can he display his 5 trophies? Well, in my mind, I saw the problem like this, where I actually lined up 5 different spaces for trophies. Say I had those trophies and I put the first trophy in its spot. I have 5 choices for which trophy I want to put in that spot. But once I've used that trophy, the next place only has 4 choices. 3 choices for here, 2 choices, and 1 choice there. Using fundamental counting principle, that tells me I have 5 factorial or 120 different ways that I can display those 5 trophies. How about that local lottery? Now, the lottery has 4 digits. That means that 1, 2, 3, 4 spaces have to be filled. Now, those randomly chosen 4 digits with repeats allowed range from 0 to 9. That actually represents 10 different digits. Since repeats are allowed, the number of different ways that I can put those digits together would be fundamental counting principle again, 10 times 10 times 10 times 10, or 1 with 4 zeros. 10,000 different ways. There's 1 winning ticket. Maybe you picked it, maybe you didn't. But your probability would be 1 out of 10,000. So what are your odds? Well, odds and probability aren't the same. Probability is 1 out of 10,000. That is the wins over the total tickets. Odds represents wins to losses. So if I take that 10,000 and I subtract off that 1 winning ticket, I get 9999. So those are my odds that I will win the lottery. A soccer team has 14 players. 2 are randomly selected to be captains for the day. Note in this case that it doesn't matter which order those soccer team players were chosen in. They still get the same position of captain. So instead of permutations, this one has to be combinations because order doesn't matter. I have 14 players to choose from, and I'm choosing 2 of those players. 14C2 is equal to 91. This 4-foot by 4-foot dartboard, which gives me 16 square feet total, has a 2-foot square target. What's the probability that a random throw hits the target on the dartboard? This is a geometric probability. It's 2 square feet out of 16 square feet. If you simplify that, I get a probability of 1/8. Number 6 requires a little bit more room because I'm going to draw a tree diagram. It says that my bag of candy has 4 lemon and 5 lime flavored sour balls. So this will be the lemon and this will be the lime tree branch. If I'm choosing 1 candy at random, there's a 4/9 probability that I get a lemon and a 5/9 probability that I get a lime. If the lemon was chosen, I can choose lemon again, or I can choose lime. Here, since one of those candies is gone, there's a 3/8 probability of a lemon and a 5/8 probability of a lime. You can do lemon and lime over here as well, but my interest is in whether or not they are both lemon flavored candies. So to find that out, I'm following this branch here. I know I multiply down the branches, so I get 4/9 times 3/8, doing a little simplifying here. I get that I have a 1 out of 6, 1/6 probability that they are both lemon flavored candies. 7 also requires a little bit more work. It's an expected value calculation. I have blue, red, yellow, green, and purple. Blue, red, yellow, green, and purple. There are 5 tickets, 1 of each color, so these all have a 1/5 probability of being chosen. But they have different values. It says that primary colors, blue, red, and yellow, have a value of 100 points, and secondary colors, purple and green, have a value of 200 points. Running this calculation, taking that 1/5 of 100 over and over and over again, 20s here, and then the 1/5 of 200 produces 240s, tells me that the expected value of a ticket pulled from that bag is 140 points.